This episode is sponsored by Audible. We generally think of spacefaring civilizations as being very technologically advanced, but what if some species have to settle for doing things the old-fashioned way? Today we're going to contemplate some scenarios in which a civilization might begin engaging in space travel, even though they're at a lower level of technological development that might seem ideal for that undertaking, and in the process ask what the minimum technologies really are for space travel. We've got four basic paths we're going to look at for that purpose. One will be a civilization that arose in circumstances where space travel was easier, another will be a case where they had higher technology then lost it or opted not to use it, and we'll also look at a case where there just isn't any new and useful science and technology beyond what we essentially have now. We've one more too, which is where they are forced to get into space in the face of a looming disaster like a giant asteroid headed toward their planet that they can't blow up or divert, and need to get some remnant of their civilization off-world before it hits. Of course, low-tech is a subjective term, because science and technology don't really lend themselves to easily defined levels. A civilization might have mastered making fusion reactors but never explored genetic or cybernetic enhancement. They probably would need to have equaled us at least in computing capability to achieve fusion, given that our own research on the matter is very computer intensive, but might later abandon higher computing out of fears of artificial intelligence, while retaining the knowledge of how to build a fusion reactor. For today we'll go ahead and define modern humanity plus maybe a couple decades as essentially our borderline. For today's purpose, low-tech will include everything we currently have either in active or past use, or very firmly on the drawing board. Technology where there's no debate it can be done, just minor technical, economic, or other practical issues to resolve. An example might be a nuclear rocket. That technology is very solid, but since we're hesitant to use radioactive engines, we don't really know its specific performance values like we do for the various rocket designs we've actually tried. Similar concepts apply to solar sails. We can calculate with ease the performance a specific solar sail would have based on its solar cross-section and mass. But since we haven't been mass-producing and using them day to day, the practical issues of building, maintaining, and using them are completely speculative. So what is the absolute minimum technology needed for spaceflight? The answer, as so often is the case, is it depends, because in theory you could have life evolve in space itself, and we explored that notion more in our episodes Void Ecology and Space Whales. Ignoring that scenario though, we have to recognize that Earth might not be the normal case for getting into space. Many tiny changes could permit a much easier pathway to orbit. As an example, there is no particular reason to think that mountains on a planet couldn't be high enough to extend up to the edge of an atmosphere. Now we have something called the glacial buzzsaw, as glaciers are far more erosive than rain, but this maximum height, where a sheer rate of rock piling up combined with glaciers piling up on it and eroding it, is going to be very dependent on the planet's gravity, tectonics, and atmosphere. As we saw on Mars, because gravity is about 40% of Earth's, mountains can get bigger. Indeed, Mount Everest is only about 40% as tall as Mars' tallest mountain, Olympus Mons. We have workable designs for a device called a mass driver that is basically a long railgun that can shoot spacecraft into orbit. See our episode on it for details, and its ideal place to build is up along the side of a nice tall and wide mountain, and Olympus Mons, which is not much smaller than France, makes a very nice gentle slope for a mass driver to pick up speed. Combined with the low atmosphere, especially at the top, and the lower gravity and orbital speeds, a civilization on Mars equal to us in technology and infrastructure could throw together a mass driver on Olympus Mons with great ease, and be moving thousands of tons of payload into space every day for not much more cost than we move thousands of tons of freight around on rail lines. Now there's pretty good reason to assume no civilization would naturally arise on Mars, but planets with atmospheres and gravities in between Earth and Mars are plausible enough and might have very easy access. Nor is gravity really the big control factor on having an atmosphere that folks tend to assume. It helps, but it's more about having a magnetosphere to hold the atmosphere on. If our moon had the same magnetosphere as Earth, it could hold an atmosphere and oceans, albeit probably not over billion-year periods, as it is much less massive than even Mars. However, assuming you do need an atmosphere and surface oceans for advanced life to emerge, moons of gas giants are options. It is entirely plausible you could have a Jupiter or larger sized planet near as we are to a sun like ours be warm and with some large rocky moons who would be inside its own protective magnetosphere. Those could even be as big as Earth, and the tidal forces of orbiting a gas giant provide plenty of tectonic activity to make mountains and generate an atmosphere to help with higher leakage to space. Moreover, if a gas giant has one big moon, it probably has tons of other ones. Jupiter has over 60, and it might have large rings too, like Saturn, so that you would have an awful lot of earlier and easy targets for space development. Easier than our own Earth-Moon, since all those objects, probably including your homeworld, are much easier to launch from than Earth and far closer than Mars. So even a moon much smaller than Earth might have Earth-like conditions but benefit civilizations by not only having potentially taller mountains, but much lower escape velocities, potentially those well inside the range of hypersonic air-breathing vehicles. Additionally, civilizations arising on such worlds, as we looked at in our episode Life on a Low-Gravity Planet, might be far more inclined to be avian, either technologically or even biologically evolved that way. Which is another way space travel might be easier even on more massive planets than Earth. Thick atmospheres can be your enemy but also your friend. Earth has little hydrogen and even less helium, in spite of them being the most abundant elements in the universe, because they most easily escape from a planet. All of our current helium comes from radioactive decay of uranium in our core, and a more massive planet not only would probably have more uranium, and thus more helium production, but also be much better at retaining helium compared to Earth, where only about 5 out of every million atoms in the atmosphere are helium, and we generally get all helium from underground deposits as a result, whereas they might be able to suck tons of it out from the air if they had more. If helium were even just an order of magnitude higher, which might be the case on a planet even just 10% more massive than Earth, you might have abundant and cheap helium to use for launch assist, floating rockets, or even runways high up into the atmosphere. This is also not super high tech, so you might see a relatively primitive civilization already incorporating air travel or floating structures long before it was contemplating rockets. So too, we use helium for balloons because it is lighter than air, but air is a number of different chemicals of various masses, so you can, for instance, just barely float a pure nitrogen balloon, because while our atmosphere is mostly nitrogen, 21% of it is oxygen, which is a bit heavier. Hypothetically, you could have a world slightly less massive than Earth and farther from its sun have Earth-like temperature and atmospheric pressure because of higher carbon dioxide concentrations and less atmospheric leakage, and thus be one with not only lower gravity and thus launch costs, but a thicker and heavy atmosphere you could float above easier. Keep in mind, technology and development tend to snowball. Back in the space race days, folks tend to assume we'd have moon bases and cities by now, and we probably would have if launch costs and efforts were even just half of what they were, as a sort of developmental equivalent of compound interest. The biggest hurdle to space development is actually getting into space. Once you're up there in a big way, there's really nothing all that high-tech involved in day-to-day life or travel. You just need to be able to make airtight and radiation-proof vessels, which isn't too hard, especially when you're not constantly needing to be super frugal with your mass, as modern launch costs require us to be, at thousands of dollars a kilogram. Using a solar sail example, at Earth's distance from our Sun, they generate around 8 newtons of thrust per square kilometer of sail, which isn't a lot, enough to accelerate 1,000 kilograms, or about a ton, 8 millimeters per second, but over a month of acceleration, pushed on by the Sun, you'd be moving over 20 kilometers per second, and that's a respectable interplanetary speed. And a square kilometer of sail doesn't need to be very heavy. 1 micrometer thick, and we can do a lot thinner with modern technology, is going to give about a kilometer of sail for a ton of sail material. Folks were beating sheets of gold to a tenth that thickness over 5,000 years ago in India, and we can do better nowadays with even lighter materials like aluminum or carbon fiber, which are much cheaper than gold, of course. Spacecraft equivalents of sailboats then become possible, differing mainly in that the ship has to be airtight, and the sails are huge but ultra-thin. Airtight is relative too. You're always going to lose some air, and at a certain point, adding more hull thickness to cut down on air loss and radiation gets diminishing returns, as you need to move that ship, and oxygen is hardly in a short supply. There's a lot of ways to get oxygen, electrolysis of water or ice being one of the easiest, but we've got reactor designs that produce a kilogram of oxygen, or about the air in a cubic meter or yard, and about twice what you'd breathe a day, for around 50 million joules of energy, which sounds like a lot but is parallel to running an air conditioner in terms of power draw, and electrolysis is cheaper, it just requires water or ice, whereas virtually any rock can give you oxygen, Indeed, given that most stuff like iron, aluminum, and silicon are usually found as oxides, refining them into the pure element produces a ton of oxygen as a waste product. Also in contrast, if you've got square kilometers of solar sails or some solar cells or nuclear reactors churning out megawatts to run your engines, a few kilowatts for air replacement is minimal, and that's probably more than a small spacecraft would leak too. One can use organic approaches for air and water recycling, of course. A room for growing plants with glass open to the sun will help with that. And if you're keeping your reserve water as a fish tank, you've got air, water, plants for food, and some fish too. See our episode Life Support for more discussion of that topic. But you can get pretty low tech for keeping life support on spaceships or space habitats, at least in the inner solar system where there's a decent amount of sunlight. Though if you are using solar sails, kilometers worth of reflective sail is a lot of light, and it is pretty easy to devote a bit of that into concentrated form to be running photosynthesis or solar panels, even out past Pluto. Low-tech interstellar ships are a bit harder, because the sun really isn't available in interstellar space, so you need to be considering nuclear options for power and drives. But if you got some radioisotopes with decades to centuries for a half-life, that is a very low-tech power supply. We normally hook it up to a thermocouple to make power, such as by the Seebeck effect, which is hardly high-tech since Thomas Seebeck discovered the process 200 years ago in 1821. This is a radioisotope thermal generator, or RTG, and they are stupidly simple and low maintenance, quite capable of lasting centuries with little or even no maintenance. The only downside is that such radioisotopes are fast decaying, so you have to synthesize, not mine, your fuel. But as we looked at in the future of fission, breeder reactors for making them are not terribly high-tech either, nor is uranium or thorium in short supply. However, thus far we've been discussing this concept from the perspective of folks getting into space easier, or essentially trying to run with no more technology than we have right now. We should keep in mind that a civilization might be low-tech even if more tech is available. If you had the equivalent of space Amish, they might be fine with buying their RTGs or solar sails, or even fusion reactors off some higher tech conglomerate. And just as an example, if we had two factions in the future, one a fairly high-tech one but with a low population growth rate and non-expansionist tendency, and another that was very pioneering and into big families but not into big tech, even if the latter started out as a minority faction, after a couple dozen generations of growth, they'd outnumber the big tech faction, who might be perfectly content to sell them durable, low to no maintenance technologies. We should also keep in mind technology can get expensive. It takes huge supply chains and other infrastructure like education to keep technology running, and a lot of small colonies might just not have that and prefer to go for lower tech solutions. If your job is just running around an asteroid belt taking samples of mineral deposits, then some very cheap and durable big metal slab of a ship with an RTG powering your drive and life support gets the job done just fine. You might have nothing high-tech in there except some preferred personal luxuries and some core device for your job, like a high-tech spectrometer, but otherwise be pretty contemporary tech. This might be an economical choice, or a moral or ideological choice, or just viewed as a safety feature. Low-tech tends to be easier to fix, often more durable and easily understood to use and repair, and doesn't try to rebel against you. As we say in regard to artificial intelligence, keep it simple, keep it dumb, or else you'll end up under Skynet's thumb. Civilizations worried about artificial intelligence going haywire don't want it out far from civilization where it cannot be easily monitored or contained if it goes all kill the humans, and thus might not encourage or allow any really sophisticated AI or self-replicating technology like 3D printers outside the core areas of the civilization where it can be managed better. But rogue AI isn't the only thumb to worry about. If you've got new technology, as we all know so well nowadays, you are rather dependent on the various companies making constant updates, patches, repair parts, and fixes. At a certain level of advancement and utility, a lot of folks for a lot of applications might decide the technology that's been tried and tested for a century and is now open license is what they want to use. We have a lot of technology like that and we get more of it all the time. Oh, to be sure, we make tiny little improvements in nearly everything. Even stuff like how we make dimensional lumber for buildings or the windows in them gets new tweaks and improvements. but that is likely to plateau out, and we are talking about interstellar civilizations who need decades for the schematics for a new given improvement to disseminate to the nearest colonies via lightspeed transmission, and with voyages of centuries to those same places, you are likely to see a lot of tried and true technology come into play. Being a couple light years out from the nearest safe harbor and dry dock is not a good time to find out that your awesome new drive has glitches or burns out some vital widget it runs on that nobody expected it to. The other reality is that while more technology always helps for settling space, once you've got it decently settled, you do not need as much tech to keep it that way. A couple months back, we were looking at the notion of techno-barbarians, low-tech civilizations living in the post-apocalyptic ashes of a higher-tech culture, and we previously looked at techno-primitivism. I'm generally of the opinion that any such civilization will return to high technology fairly quickly, assuming it wants to, and thus don't view these civilizations as very likely or stable, especially given that a few generations of stability is likely to result in technology being redeveloped. However, that doesn't mean they can't operate, just that I can't see them staying very low tech for long, unless it was voluntary. Fundamentally, a spaceship built in space for running around space is just a big metal can that shoots rocket flames, ions, or reflected light out the back, and a space habitat like an O'Neill cylinder is just a big metal can you dump dirt, water, and air into and add some light, from a power plant or funneled in from the sun. You may get very high tech with these, but you also might be prone to keeping them very simple and durable to lower maintenance, especially if you're a low-tech group commissioning some company to build one for you. Buying something made by high technology that needs little maintenance and all within your skills is much more attractive than having dependence on others for keeping it working. And we never want to assume, just because we're all pro-technology these days, that future civilizations hold quite the same view. I doubt there has ever been an era that was more pro-tech than now, and most folks are still a little queasy about the dangers. And not just from ignorance. Heck, I'm a notorious techno-optimist, and I constantly mention how dangerous technology is. Someone sent me an email a couple days back linking me to the Wikipedia page with notable futurologists on it, and I was a bit surprised to be listed on there with a bit over 100 folks, living and dead, but I knew most of the names, and of those I could recall, most were techno-optimists, and folks who I've also heard warn about the dangers of high technology. That's the most outspoken techno-optimists of an era with probably the highest amount of techno-optimism in human history, and we all think the stuff is like juggling live hand grenades. It isn't hard to imagine how a civilization might change its view on this stuff, especially given that the more technology you have, the more comfortable life is, and the more picky you can be about which technologies you use to keep it that way. When we talk about post-scarcity civilizations, I tend to mention that we're already very close to being one, and that there are several different plausible technologies we might get in the next century, any one or two of which would get the job done to make us post-scarcity. So if you've got all of them, you can opt to be picky about which you employ and how. And more comfortable civilizations probably are less prone to gambling. You might use a dangerous tech to save lives, but you don't flip on a dangerous AI because it means you can upgrade from your cramped 100-room mansion cleaned by simple robots to a nicer 1,000-room mansion fully staffed by intelligent androids. We often assume higher-tech civilizations that are post-scarcity to be rather self-indulgent and soft from all the prosperity, but even if that were true, we shouldn't assume they are reckless or stupid. I suggested that you might have lower-tech spacefaring civilizations who buy their stuff from higher-tech ones, but they could just as easily have some rigid rules about who is allowed to learn certain technologies too. If you need to have AI but are pretty paranoid about it, you might seriously restrict its use and only allow the knowledge of making and maintaining it to be in the hand of a very small group of folks. You might need 1 or 2 people per space habitat to maintain some core bit of dangerous but necessary technology, and pick them not by those most intelligent, curious, or interested, but rather from those most trusted. You really need to be as smart to learn something as to invent it, so a space habitat of 1 million folks might have some huge psychological or democratic screening process for nominating apprentices to the existing maintenance crew entrusted with terrible and dangerous secrets of its function. In such a case, nothing is going to be higher tech than it needs to be, because that means sharing those dangerous secrets to more people. Also, always keep in mind the scale of things. Even if your civilization was continuing scientific research, and kept 1 million expert researchers for a given field, way more than we have now, In some Kardashev 2 Dyson swarm, that would mean that only 1 in several trillion people worked in researching that field. That's a lot of folks to be able to accept the best and brightest from, and still screen out those who are viewed as not psychologically suited for ensuring new science and tech development was handled very safely and securely, so that when technology hit day-to-day use, it was in some ultra-durable, simple, and very tested format. Also, despite how fiction often portrays scientists and engineers as recklessly pursuing new technologies, in my experience they already tend to be more, not less, cautious than most folks. I've never noted a correlation between genius and recklessness, so you probably can screen out the more reckless ones for your tech development without slowing that down much. A civilization might be very touchy about allowing any tech that wasn't necessary to be in regular usage, especially on board small crew spaceships, and it's neat to think of some kilometer-long leviathan of a space freighter being run by a crew of a dozen because of vast automation and robotics. But if you've got tons of people, they do need something to do to keep them occupied anyway, and those same technologies are going to be available to make every facet of production easier too, so you might see a lack of massive unemployment and idle hands and minds as a plus anyway. Is it likely? Maybe. We looked at 3 basic ways you might have low-tech spacefaring: those who developed at lower tech because their world was better suited for it, those who basically couldn't get any more advanced than now because science and technology cannot develop further or they don't want it to, or those who essentially opted for minimum employment of higher technology even though they had it, and either still had it or lost it. Each one of those scenarios is plausible, but more so in the grand scheme of things, as when we're talking about the endless quadrillions of people who might live in some developed star systems across the whole galaxy, there is a lot of room for variation. You might have a low-tech spacefaring civilization living around the moons of Jupiter who just bought their fusion reactors or radioisotope supplies off some high-tech conglomerate on Mars, while over on Saturn, folks eschewed most types of technology in favor of genetically engineered plants that could grow in space and be grown or woven into solar panels or sails. And a few dozen light years away there was some star system that was nothing but asteroid miners who all worked in jury-rigged ships with no AI, supplying metal for some automated mega freighters that showed up to collect the ore and trade them high-tech manufactured, super cheap but super simple goods, like RTG-powered LED grow lamps that lasted for a century and you just hung them on the ceiling of your hydroponics facility. The galaxy and the future can potentially host virtually endless variations of civilization in this or that place and time, so that an interstellar merchant visiting a system after a century might find they had gone all low-tech, or return to being high-tech and flipped around the next time they stopped there. That is one neat thing about our future as a spacefaring civilization. The path to all those new stars offers a path to near endless options for civilization. And while technology helps a lot for getting there, as we saw today, your spaceships don't have to be all that high-tech to make the voyage. Science fiction is full of examples of low-tech spacefaring civilizations, or those who went low-tech after colonizing a world, but one of my favorites is Anne McCaffrey's Dragon Riders of Porn series, and indeed it was the second fictional book series I read, right after Douglas Adams' Hitchhiker's Guide to the Galaxy. Or I should say listened to, as what got me as a kid into fiction instead of just non-fiction books was being able to listen to the stories as audiobooks. While masquerading partially as a fantasy series, right from the very first book written in 1968, and there are dozens in the series now, we see a civilization that was built by science and still retains some higher technology. It also includes an alien invader that is so low-tech it doesn't even use spaceships. Over the years, a lot of books were written chronicling the planet of Porn, all the way from the spaceships arriving to colonize the world, to them losing their technology in increments, and finally regaining it, complete with some novel approaches to spaceflight. It's one of my favorite series, and as we head into the colder months, if you're looking for a good story to occupy many weeks, then the Dragon Riders of Porn is a great choice, and the series is our Audible Book of the Month. You can choose to start with the first book written, Dragon Flight, or head to the beginning of the chronology with the more science fiction themed Dragon's Dawn, and they're all available on Audible. Audible also has podcasts, guided wellness programs, theatrical performances, and exclusive Audible originals. Indeed, they have over 3 centuries worth of audio if you just hit the play button and ran through every title. If you want access to that massive collection of great audiobooks, like Anne McCaffrey's Dragon Riders of Porn, you can join Audible for a 30-day free trial. And Audible members not only get discounts on any audiobooks they buy, but a free book every month. Additionally, they are now giving unlimited access to their Audible originals. You can start listening today with a 30-day Audible free trial. Just visit the link in the episode description, audible.com/Isaac, or text Isaac to 500-500. So we talked a lot about how a low-gravity planet like Mars might have an easier time getting into space than we had on Earth today, and next week we'll be looking at the challenges of getting to Mars from Earth and setting up a base there, as we continue our new series, Becoming an Interplanetary Species. The week after that, we'll be having our Halloween special, Terrifying Aliens, on Thursday, October 29th. But before that, on Sunday the 27th, we'll have our monthly livestream Q&A at 4 PM Eastern Time. If you want alerts when those and other episodes come out, make sure to subscribe to the channel. And if you'd like to help support future episodes, you can donate to us on Patreon or our website, isaacarthur.net, which are linked in the episode description below, along with all of our various social media forums, where you can get updates and chat with others about the concepts in the episodes and many other futuristic ideas. Until next time, thanks for watching, and have a great week.